Which are the questions you want us to take a look at? Are there any, I guess there are particular ones you wanted us to look at, right?
Yes.
Okay. So which ones are those? Should I start from the bottom?
Yes.
Okay. All right. So the last, I think this is the last question. 26. Okay. So should we do this one? Should we work on this one?
Yes.
Okay. All right. So this is the last one. It's this first one has to do with inequality. And you remember what I said about inequality, that inequalities are similar to equations. The only difference is that there are some set of rules that apply to inequality that don't apply to equations. So those are the things we'll just be taking note of. But solving it is the same thing. Now, anytime you have a fraction like this, you know, a denominator for one of the terms in your inequality or equations, always check, right? If that's the only denominator, then you are free to use it alone. But if you have two denominators, meaning, for instance, 5x over 2 and maybe 18 over 5, something like that, if you had something like that, okay, then you would have had to find the LCM first, okay? But since it's only 2, in this case, we only need to use 2. We don't need to find any LCM. So let's hit the road. So what are we going to do with 2? We're going to multiply each of these terms by 2. So that's going to leave us with 5. Sorry, let me write that 5 well. 5x, okay, over 2 times 2, okay, plus 3 times 2. You now put your sign there, greater than 18 times 2. Okay. Now remember, this step that we just took now was because the denominator for 5x over 2 is actually 2. Okay. So why do you think we're trying to multiply all the terms by 2? Why do you think we're doing this? Can you guess?
To get rid of the bottom two.
Exactly, to get rid of it. Yes, exactly. You're correct. So you can see this has helped us to get rid of 2. So what we'll now have will be 5x, the 2 will no longer be there, plus 6, because that's 3 times 2, that's 6, greater than 18 times 2 is 36. Okay? Can you see what we have now?
Yes.
Moving on, collect the like terms. Of course, you know better that 6 should go to the right-hand side. So I'm left with 5x greater than 36 minus 6, because the 6 was positive on the left-hand side. So it will become negative on the right-hand side. I'm now left with 5x greater than 30, right? What do you think we'll do next?
of divide 30 by 5.
Yes, divide both sides by 5. So that's going to take this guy out, 5, 5, and divide here by 5. Now, did you see in all this, the inequality sign remained the same? Why? Because none of the rules were activated. You know, that's usually what happens with inequality. The sign usually changes, okay? So none of the rules were activated. Now, just as a reminder, before we leave this question, so that's the answer, x greater than 6. Just as a reminder, before we leave this question, sometimes inequality questions, they may ask you to represent your answer on a straight on the number line. So if I were to represent x greater than 6 on the number line, it's very simple. I'll simply do this. I'll draw my number line, right? Gauge where, just put a gauge for where 0 could be, okay? 6 will be on the right-hand side of 0, right?
Yes.
Okay. And then we'll now remember it's x greater than 6. All the numbers to the right-hand side of 6 are greater than 6, aren't they?
Yes.
So this is how your graph will look for this particular question. Now, can you see I did not shade this circle? I didn't color it. Why? Because the answer didn't include anything like equals to, greater than or equals to. Had it been it included equals to, I would have had to do this. Okay, this is what I would have had to color it. Now, coloring that circle means 6 is included. That's what equals to, greater than or equals to means. Okay, but since 6 is not included, I didn't need to color it. So I'm just going to take those ones that I added now out because they are not part of the, they're not part of the, they're not part of the answer. So I'm going to just, let me just take them out. Okay. All right, I'll draw that back. So my correct answer is x greater than 6. And then here, the circle is, small circle is not shaded. Okay, so did you get that?
Yes.
Okay, now what I wanted to say, what I wanted to remind us of is the rules for what? Inequality. So I'll quickly say it and maybe, I don't know if we can illustrate it, but the rules for inequality. Number one, okay, so the rules are basically these. The sign, by the sign, you know what I mean, right?
Yes, the greater than or less than sign.
Yes, yes. So that is either greater than or less than. Okay. The sign reverses. So this is just basically what happens. The sign reverses when either of these things happen. Okay. Number one, you multiply. I just realized now that I was basically typing, so I didn't need to, sorry, I didn't need to use that. Let me just type it out. Okay, come on. I don't know why this thing is dragging today. Okay, so the sign reverses when one, you multiply or divide. Okay, sorry about that. Both sides by a negative number. Okay, a negative number. Okay, I think I should move that to the next line. Or I think I can move everything. Yep, I can. Okay, by a negative number. That's rule number 1. Number 2, another thing that causes the sign to reverse is when you take the reciprocal of both sides. Okay, in brackets, invert both sides. Okay, and that just simply means making the denominator the numerator and making the numerator the denominator. That's what taking reciprocal of both sides means. Okay, then number 3, I think there's a third one. When you switch sides. Okay, so what is it? When you switch okay, all right, sorry about that. When you switch sides for the unknown, and the number. Okay. So what that last one means is that, for instance, if we wanted to say put 6 on the left-hand side and X on the right-hand side, this sign cannot remain the same. You have to reverse it. Okay, so I'll just leave it there. All right, any questions on this? Can I move on? Hello, Noah, are you there?
Yeah, yes. You know when the circles I know they'll color in the circle at some point, but when they do that, that means that it's equal to, right?
Yes, yes. When you color the circles, yes, that means there's an equal to there as part of the inequality. Okay. Okay. So can we move on now?
Yes. Yes.
All right. So it says factorize x squared plus 10x plus 9. All right. So to factorize a quadratic equation, there are different methods. Okay. But the simplest method I know is to ask yourself a couple of questions after doing this. X squared, okay, x squared plus 10x plus 9, right? All right. So ask yourself, what 2 numbers, okay, 2 numbers find 2 numbers whose sum, again, I forgot. I can type this. I can't type this. I don't need to illustrate. Okay, let me do this. Okay, so find 2 numbers whose, sorry, my keyboard acts up sometimes. Okay, whose sum is, in this case, 10x and product is 9x. Sorry, not 9x. Let's just say 9. Okay. So find two numbers whose sum is 9, okay, and whose sum is 10 and whose product is 9. Now, why is it that the first step is for you to do this? Because you are going to be replacing that 10x very soon. Okay, you're going to be replacing it very, very soon. So this is how you're going to replace it. Now, can you think of two numbers whose product is 9 and whose sum is 10?
Three. Oh,
Did you say 3? So you see what I usually do with this question is this. I quickly start thinking of my multiplication table. Yes, what comes to mind sometimes for the first time may not be correct. So let's give it a try. Now 3 times 3 is 9, but is 3 plus 3 10? No. So that's where that one fails. So we need to find two numbers such that when we multiply them, the answer will be 9. But when we add them, their answer will be 10. So what two numbers do you think are those?
wait, does it have to multiply to 9 or multiply to 10?
Yes. You multiply them, you get 9. You add them, you get 10. Okay, so now it may not be too apparent, but guess what? 9 and 1 will solve that problem for you. Can you see that?
Oh, yes.
Yes. So look at what we're going to do now. This is what we're going to do. We're going to replace, remember I told you we're going to replace 10x. And that is the reason why this sum, why we are always asking questions for sum for the middle term, the one that has the x in it. And then product for the last term, the one that doesn't have x in it. Okay, so we're replacing 10x now because we know that 9x plus x will give you 10x. This is what we're going to do. We're going to have 9x, okay, plus what? X, isn't it?
Yes.
There's no need for us to put the 1 in front of the x because everybody knows that there's a 1 there. It's understood that there's a 1 there. All right, so this is how it looks, okay? X squared plus 9x plus x plus 9. Okay, now I know somebody may say, why didn't we switch? Okay, well, whether you switch sides or not, we will still get the same answer. This is how we'll go about it. Now, the question you'll be asking yourself is, we're going to group these two together, right? And we're going to group these two together, okay? Now, what do you find common between x squared and 9x? What's common there that we can factorize? Remember, the question is for us to factorize. So what's common between x squared and 9x?
X.
X, thank you very much. So I have x. You open a bracket because you've already started the factorization. When you factorize x out, you'll be left with x inside. That's from that x squared. And then when you factorize x out of 9x, you are left with what? 9. Now, this is the easiest part of this work. All you need to do now is to find a way to make sure that you get another bracket that looks like this from this guy, from this second one. Just make sure that you get a bracket that looks like this. And from what I can see here, x plus 9 already looks like x plus 9. So guess what I'll simply do? I'll simply say that 1 is common. I'll write them just exactly like that. Did you see what I just did now?
Yes.
Did you notice it?
The 1.
Remember, the whole idea is for you to find what is common between those two numbers, right? And to make sure that you have a bracket that is exactly identical to the first one. Now, again, I said, when you look at what's happened, what came out in the bracket here, it looks exactly like what you have here. So all you just need to do is to safely assume, it's not even an assumption because it's true. 1 is a factor of all numbers, right? So factorize 1 out. And when you factorize 1 out of anything, it's that same thing. Did you get that?
Yes.
Okay, so we're going to move on now. Now that we have two brackets that are similar, all we now need to do is to take one of them. We'll just write one of them on the next line, x plus 9. And then we'll close the bracket. And then we take the numbers in front of the bracket. In this case, x is in front of this one. And then plus 1 is in front of this one. And that's going to give us x plus 9, x plus 1. Okay, so that's the answer to this question. Did you understand the steps?
Yes.
Okay, so the main part that you may spend time on is the first step.
Mm.
Do you agree with that?
Okay, yes.
Yes. Okay, so can we move on now?
Yes.
All right, so I'll send you this annotated one after the class. Okay. Oh, this guy looks familiar. Do you want to attempt it? Okay, anyway, let's do it together. It says a storage tank exerts a force of 10,000 newtons on the ground. The base of the tank in contact with the ground is 4 meters by 2 meters, is a 4 meters by 2 meters rectangle. Remember, yesterday's question, it was a cylinder. Today's question is a cuboid, okay? But whichever way, the principle is the same thing. It now says, work out the pressure on the ground due to the tank. Now, pressure is given by force per unit area, or force divided by area. Remember, I told you that word per unit means division, okay? So force per unit area. So we have been told that the force is what? 10,000 newtons. So all you just need to do is to calculate the pressure. It's very, very easy. P will be equal to what? 10,000, 1, 2, and 3 divided by area. The area, since the is the bottom that the pressure is on, right? And they told us that the base of the tank in contact with the ground, that's where the pressure is what? A 4 meters by 2 meters rectangle. So all we need to do is to do what? Multiply 4 by 2, because the area of that rectangle is what? Length times breadth, isn't it?
Yes.
So that's going to give me 10,000 divided by 8. Now, if you don't want to do it the way I'm doing it, okay, I think it's safer. Let's do it this way to avoid confusion. So 10,000 divided by 8. Now, you can simply, to avoid wasting time, you can say 8 into itself, 1. Now, please just follow me. 8 into 10. How many times will 8 go into 10? 1, isn't it?
Yes.
Do you agree with that? Remember 2, right?
Yes.
Sorry, that 2 didn't show up well. Let's wipe it out. So that's 1 time remainder 2. I'll put the 2 there. Now 8 into 20 is 2 times, because 8 times 2 is 16. That's the closest to 20. And that's going to be 16 remainder 4, right? Did you get that? Eleanor, are you there?
Yes.
Okay. So that's 8 remainder, 2 times remainder 4. 8 in 40 is 5 times, because 8 times 5 is exactly 40. So, and then finally, 8 in 0 is what? 0. Did you see what I just did back there? I used 8 to divide directly, instead of, somebody coming to say, oh, let's start with 2 or start with 4. It will waste your time. I can assure you, you will get the same answer with me, but the time that you've wasted will not be a good thing at all. So that's the answer, Newton per meter square. So you can either write it like this or write it the way they wrote it here. Okay, either of them is still the same thing. Now, if you look at it very well, the reason why this -2 meters raised to power -2 is the same as slash meter squared is simply that you remember that rule of indices, that when you have a negative power, it's just the same thing as moving that number underneath and leaving it with the positive power. It's a law in indices. So any question here?
No. Wait, so
Okay.
4 times
Okay.
2 was
All right.
the area.
Yes, what did you say?
So 4 times 2 was the area.
Yes, the 4 times 2 was the area, because it's a rectangle, right? And the area in this case is whatever is the shape that is at the bottom. So since the shape at the bottom is the rectangle, we had to find the area of that rectangle.
Oh, okay. So,
Yeah. Okay, so we're moving on. So do you want us to just go through all the questions like we did yesterday?
no, because I can solve some of them. So
Okay, all right. So what you will do for me is, when we come to a particular question, let me know the one you can solve and you're really sure you can solve, so we can skip that one. Then we'll go to the one that you can't solve. So is this a question you can solve?
oh yes.
Okay. Okay, that's a ratio question. How about this one?
No, I don't understand this one.
Okay. All right, so let's solve it together then. It says a car factory is going to make 4 different car models, A, B, C, and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information about the results. Okay, so 23 people said they want A, 15 people said they want B, 30 said they will most likely buy C, and 12 said they will most likely buy D. It says that the factory is going to make 40,000 cars next year. Work out how many Model B cars the factory should make next year to cater to the statistic for the Model B people. Okay, so now you need to understand that that 80 there is just a random sample number, right? It's like what you do in statistics when you take a random sample, a small number, and use that small number to represent what will happen in a real population. So what that means is that for 40,000 cars, right? Model B, from that sample, we had 15 people. Remember, the total was what? 80. So what that means is that for Model B cars, we're going to have 15 over the total 80 times what they want to produce, which is what? 40,000. 40,000 is the total they want to produce next year. So they're saying out of this 40,000, how many of them should be Model B cars? So that's what we're about to find out. So this 0 will cancel one of these zeros, and 8 will do its favorite thing, taking itself out. 1, 8 in 40, I just said it less than 5 minutes ago, is 5. All these ones, there's no remainder, so you just put your 0 and 0. So you are left with 15 times 500, and that is another easy calculation to do. Just multiply 5 by 15, and 5 by 15 is 5 times 5, 25. 5 carry 2. 5 times 1, 5 plus 2 is what? 7. Okay? Don't forget the 2 zeros behind the 500. 1 and 2. So we're going to have 7,500 Model what? B cars. Did you get the gist of this question?
It's 500.
Did you understand the question? Sorry?
So you did the amount of B people over the whole amount of people, and then you just multiplied it by
The total number of cars, right? Yes.
yeah.
Yes, that's the whole idea.
Mm.
Okay, so did you get the concept?
Yes.
Okay. All right, so can I move on now?
Yes, yes.
Okay. Can you do this one?
Yes, yes.
Okay. Moving on then. Are you sure you can do this one, these indices? Because this one is a different question. I know you can do this one. This one is quite straightforward. It's just multiplication. But I don't know your stand on indices, if you're good with it.
You just add the two the two inside numbers, right?
Okay, that's the starting. Yes,
And then
you add the 2 powers inside, so that will give you, yes, and then
you multiply it to
that will
the
give you 2 raised to power 3.
you multiply it by two.
Okay, yes, that's it. That's 2 raised to the power 6. Yeah.
Okay.
Yes. Yes, you're right. Okay, so you're good. All right, we'll move on. Okay, so I'm here. Can you do this one?
Once it's yes.
Both of them. That's the A and B.
No, I don't know about B, but I can do A.
Okay, you can do A. Okay, so let's quickly do B then. So it says show that 2 whole number 2/3, right? Divided by 6. That is the part that will trip so many people up. And it doesn't look like it's a question that can trip up. But you see that a lot of people are going to trip up on that. So show that this is equal to this. That's our job. To just make sure that we do everything mathematically correct to show that this side is equal to this side. Okay, let's hit the road. All right, so the first thing we're going to do is to turn this guy into an improper fraction. Improper in the sense that the numerator will be bigger than the denominator. So how do you do that? Simply multiply 3 by 2. That's the denominator by the whole number. So that's good. You are going to have 3 times 2, 6. Then add the guy on top. 6 plus 2, 8. So you have 8 over what? Over 3. I believe what I did now was quite straightforward, right?
Yes, yes.
Did you understand it up to this point?
Yes,
Okay.
I do.
Now, in mathematics, anytime you see a division sign and fractions are involved, you can change it to what? Multiplication. Okay. But when you change it to multiplication, don't forget you must invert whatever comes after that division sign. Now, when you have a whole number like this, always in your mind, see that whole number as that whole number over what? Over 1. So that if you have to invert, this is what will happen. The one that was under, you remember when we were talking about inequalities, invert, take the reciprocal. This is what I meant. Thank God we have this question to help us demonstrate. This is what I meant. The denominator becomes the numerator, and the numerator becomes the denominator. Okay? So we're ready to divide, right?
Yes.
So what do you think can go into 8 and 6 without a remainder? Quickly. What do you think can go into 8 and 6 without a remainder?
Yeah,
A common factor for both 8 and
I thought it was a common factor for 3 and
what
6.
did you say?
Is it not a common factor for 3 and 6?
No. Now, when you would have been looking for in fact, you'd be looking for a common multiple, the lowest common multiple for 3 and 6 if these times were either addition or subtraction. But that's not the case here. We are doing multiplication. Okay, so we're not doing 3 and 6. For multiplication, you always do across. That's this guy and this guy. Okay, so we're looking for something that would divide 8 and would divide 6 without any remainder. What number do you think that would be? What number do you think that would be?
2.
2. Thank you very much. So 2 in 6 will give me 3, and 2 in 8 will give me what? 4. Can you see how our proof comes out?
Yeah.
4 times 1 is what? 4, And 3 times 3 is what?
9.
9. So it's quite okay for you to, I don't know if you used to do this whenever you do your working in school, but you can do a QED thingy. Okay, so I know QED means something, but it's sometimes people say it's an acronym for quite easily demonstrated, QED. Okay. If you don't want to use it in your exam, it's fine. All right, so let's move on. Do you have any questions?
No.
All right. So don't worry about writing because that one in its own self takes time. I'll send you this annotated PDF when I'm done. I'll save it and send to you. Okay, so here we go. Are you good with this?
Yes.
I'm sure you can do number 19, right? This one is a piece of cake for you. Okay. How about this one? Number 18.
So first you find the actual amount of each can, right? And then you do then you find the fraction of the can you're looking for. The can.
Okay. Okay, yes. Yes, that's what you would do for this. Yes, that should fly. I think it would fly. Yeah. Okay, so I think we can move on then, since you can attempt that. Okay. Number 17 is a mouthful. There are only blue counters, green counters, red counters, and yellow counters in a bag. Table shows the number of blue counters in the bag, 30. It didn't say anything for green, but it says there's a total of 100 counters in the bag. Ashin takes at random a counter from the bag. Find the probability that the counter is not blue. Can you answer that question for me? What should we do in that scenario? What's the probability that the counter is not blue?
30 over. Wait, so not blue. 70.
Yes, not blue. What did you say?
70 over 100.
70 over 100. How did you get 70 over 100?
Because 30 are blue, so the rest would be 70.
Okay.
Because there's 100.
Okay. Okay. The ones that are not blue, right?
Yes.
Okay. Now, another way of saying what you just said is this. Total probability is 1. So if probability of blue is 30 over 100, then probability of it not being blue will be 1 minus 30 over 100. And since 1 is the same thing as 100 over 100, by the time you do 100 over 100 minus 30 over 100, you'll simply get 70 over 100. So yes, you are correct. So we move on. It says the ratio of the number of blue counters to the number of green counters is 2:3. It says work out the number of green counters in the bag. So that should be easy, right? It says you should work out the number of green counters in the bag. So what do you think would be the number of green counters in the bag?
If blue are 2 plus 5.
So it says blue, B is to what? Is to G. And that's what? 2 is to 3. So that's basically what we have. So that's going to be for green counters, right? That's going to be 3/5, isn't it? Times 100, right?
Yes.
Okay. So what would that be? Now, I'm sure that you've heard me saying some things, so you get used to it. 5 in itself is 1. 5 in 100 is 20, plus 5 times 2 is 10. So by the time you say 5 in 10, 2, 5 in 0, 0, that's 20. So you're now left with what? 3 times 20, which is what? 60. Do you agree with this?
Yes.
All right. Then is Bradley. Bradley says what? The number of red counters in the bag is the same as the number of yellow counters in the bag. Can Bradley be correct? Give a reason for your answer. Well, let's see if Bradley is correct. Now, you know there are some things we cannot be so sure about in this question, because right now we only know the number of blue counters and the number of what? Green counters. So I want you to imagine for a moment, right? The number of blue counters. Blue is what?
30.
Is 30. The number of green counters is 60. Is it possible? Green is 60. Green equals 60. Okay. So how many will be left for the other guys? 30 plus 60 is 90 already, isn't it?
Yes.
And they said there are 100 counters in the back. So that means the remainder is 10. Can we share 10 between red and yellow equally? Because it's saying for the number of red counters in the bag is the same as the number of yellow counters in the bag. It's possible, isn't it?
Yes.
If you think about it. So yes. The question, you see how they ask the question, can Bradley be correct? Yes. So it's a possibility. So I think we can say yes. Yes. And that would be red. Red would be what? 5. And yellow would be what? 5. Okay. All right. So let's move on. Can you do this, guy?
Add all this sides, then collect the light times.
Yes, thank you very much. Collect the like terms. You create an equation from this guy. It's giving you perimeter. So you just simply add all the sides and collect the like terms. And then at the end of the day, you will find what x is, and then go and put it in 2x multiplied by 2. That's the length of DC. You're very, very, very correct. I'm sure you can do this. Can you do you remember how to do this? I showed you the formula for this in the last class. Can you remember that formula? If you remember that formula, that's what will help you do this. For the midpoint, formula for midpoint of a line. Sometimes it's a line, sometimes it's 2 points. The midpoint between 2 points.
Mm.
Do you remember the formula?
Oh, yeah. Yes.
Okay, so what's the formula?
X1 plus X2 over 2.
Yes.
And
Y1
plus Y2 over 2.
Okay, that's fine. You remember, that's good. Okay, let's move on. How about this one?
Is this speed multiplied by time?
Speed multiplied by time. Yes, to find distance, right? Yes, correct. That will be it. Yes, you're right. Okay. So I'll take it that you can do this, guy. And we can move on. Okay. How about this one? I think this one, you're just simply reading from the graph, right? So I think we can move on. How about this one? Can you do it?
Yes.
Okay. These ones look like transforms, right? Reflection and all that. How about this one?
Yes.
Okay.
The
All righty. Which one?
number 10 is 24, sorry, 23 divided by 4, right? And then round it because
Number 10. Let me take a look at it properly. The shop sells jars of coffee. Each jar of coffee costs £4. Michael has 23 pounds. Work out the greatest number of jars of coffee that Michael can buy. Yes, 23. So you know, yes, I'm not sure if you said 24 or 23. I'm not sure I heard you right. But it's actually 23. Now, 23 divided by 4 will give me, it's almost 6, but it's not 6. It's going to be 5 remainder 3, right? So since we don't have 3/4 of a jar, let's just pretend that's not possible. Then we have 5 jars. So 5 is the highest number of jars of coffee that Michael can buy. So yes, you're right.
Okay.
So it's a division operation. Okay, so can we move on?
Yes.
Okay. How about this one?
Yes, yes.
Okay. What's the mathematical reason for you to solve this guy?
Angles around the center.
Angles at around the center or angles at a point, isn't it?
Yes.
Okay. Angles at a point sum up to what?
360.
Correct. So that's the reason for your answer. Okay, moving on. So there are two questions here. Let's start with number 7. Can you do number 7?
It's the most common, right?
Yep. The most common, the most frequently occurring letter. So that would be A, isn't it?
Yes.
So it says one of the 8 letters is going to be picked at random, right? On the probability scale with a cross X, the probability mark with a cross X, the probability that this letter will be B. Okay, so there are only 2 occurrences for B. That's going to be 2 divided by 8. And that's going to be 1/4. And 1/4 is in between half and 1. Sorry, did I just say half and 1? It's in between 0 and half. So it's going to be here. Do you agree with that?
Yes. 1, 2, yes.
Okay. All righty. So we move on. That's 1/4. Okay, it says find the probability that this letter will be C. How many C's are there? 1. That's simply 1/8, isn't it?
Yes.
Okay. So can you solve number 8? Look at number 8 very well.
You would move the 3 and then it'll become positive, right? So M
So
equals
M will be equal to 7, right?
yes. For the bottom one,
You collect like terms, right?
yes.
Okay. That'll be 4n equals 24. And then you now divide both sides by 4 to have n equals 6. Okay, moving on. How about this guy? There are 2 questions here. So look at number 5 and then look at number 6.
15 WT.
Yep. Yep. All right. How about number 6?
Yes.
Okay. All right. All right. All right. Moving on. Okay. And we're right at the top. I guess you can handle this, right?
Yes.
0.3 as a fraction is going to be,
3
you
over 10.
take your 1 for the decimal point, 3/10. So that's 3/10. The next one, it says work out what? 3 squared. 3 squared is 3 times 3, which is 9. What will happen in this guy? 20 divided by 3 plus 2.
3 plus 2 divided by 20, so 4.
Yeah, that will be 4. That will be it's as good as 20 over 3 plus 2. That's 20 over 5. Which is 4. Okay, next one. Write down a factor of 60 that's between 8 and 14. Off the top of your head, what are the numbers that when you multiply them will give you 60? That you know.
6.
Okay. 6 times 10. But 6 and 10, none of them lie between 8 and 14. So those guys are disqualified. What other number do you know that when you multiply them, they will give you 60 from your times table?
5 and 12.
Okay. Yes, 5 times 12. Yes, correct. So 12 is the number that we're looking for because 12 can be found between 8 and 14. All right. So that's it. Okay. So is there another paper you want us to look at before our time is up?
No,
Let me
because
save this so that I don't forget.
no, I only have actual papers, so
Oh, okay, okay, okay. Do you have like a scanner app on your device
that does what?
that could convert pictures to PDF? So if you took a picture of the actual papers, it would convert it to a PDF. Then we could use it for class, or I don't know.
Um,
Or you could take a good picture of it and then send to me. Anyone you wish. I just thought about the scanner app because that one would convert it to a PDF. It must not be a PDF, it can be an image. Is this something that you can do or you would like us to do?
let me take pictures of this paper and send it to you.
Okay, all right. Okay, I'll be waiting. Okay, I've seen the pictures you sent. Just these two, right?
No, no, no,
Okay, I'm downloading the ones you sent already.
okay.
Okay, you just sent one more. Okay. Mm. Okay, you sent two more. Let me see. Let me download those. Yeah. Okay. Okay, so we have 5 altogether. Let's see. Let me try and open them individually. Open with Paint. Okay. Okay. Okay, I think I'll just okay, so we can start working on these ones, right?
Yes.
Okay, nice. Nice. Okay, can you see my screen?
Yes.
Okay. All right. I'm trying to get a setting for the pen. So, okay. Okay, so I'm looking at this question. It says the first 5 terms of an arithmetic sequence are 1, 4, 7, 10, and 13. It says write down an expression in terms of n for the nth term of this sequence. Okay, this question looks familiar. It looks very much like that one that we did, one of the ones that we did yesterday. So let's simply follow the same method. So I'm going to write down the formula, the general formula for arithmetic sequences. Okay, sorry, let me change the color so that it would stand out. I think a red is nice. Red somehow stands out. Okay, so the general formula for what? Arithmetic sequences is given by Tn equals A, the first term, plus open brackets n, that is the nth term, minus what? 1. And don't forget your common difference, D. Okay? Now, from this particular example or this particular question, my A is going to be the first term, which in this case is 1. Okay, just look at the very first number that's there. That's 1. And then you can now put your plus sign, plus Your n is general, so just go ahead and put it there. No big deal with it. Then put your -1. Those ones don't change.
I understand
That's part of the formula. You understand what?
I understand the first one. I understand the first
Oh, okay, okay. So which one do you want us to look at? The second one?
second one. Yes, please.
Okay, all right. Okay, so it says we should show that this side is equal to this side. Okay, so again, it's multiplication. In this case now, you are very, very free to make both of them to be improper fractions. So that's going to be 3 times 2, 6, plus 1, 7. So that's going to be 7 over 3 times 4 times 3, 12, plus 3, 15. 15 over 4. Okay? Remember, this is multiplication, so we go across diagonally, right? So 3 will take itself out 1 time, and 3 will go into 15. How many times? 5 times. 7 and 4 are not compatible in the same manner, so we have to leave them like that. 7 times 5 will give me 35 divided by 1 times 4 will give me what? 4. So let us see if 35 over 4 will give us 8 whole number, 3 over 4. So from your times table, your multiplication table, you know that 4 in 35 is 8 times. Why? Because 4 times 8 is 32. That's the closest it can get to 35. So that's going to be remainder 3 over 4. So, and you see that your numbers are playing nicely there.
Yes.
Okay. All right. So can I move on now to the next one?
Yes, please.
Okay. So I don't know if you, maybe I will send this back to you the same way I'm going to do for the questions. So I'm going to save the changes I made to this and close it. Okay. Sorry about that. I think I should just share my whole screen. Okay. All right. So I think this is the first one I just opened. Let's go for the second one. Let's just say edit. Okay, so I need to zoom out a bit. Okay, can you see my screen now?
Yes.
Okay, so it says, given that A over B, sorry. Change the color to red, or maybe I should make this one blue. Let's see how blue will look. Okay, so given that A over B equals 2 over 5, and B over C equals 3 over 4, okay, find A is to B is to C. Now, you know, somebody will be thinking, how come B is looking like it's mapped to 5 here, and B is looking like it's mapped to 3 here? They don't seem to match. So what should we do? I'm going to basically interpret it the way it is, right? So A, okay, that doesn't look nice. Sorry, I have to take it back to red. Okay, so I'm going to say A is to B is equal to what? 2 is to 5. Okay. Is this the best way to go about it? Okay, no problem. I think I know what to do. Let's go back a bit. Okay. So remember the question told us that what? A over B is equal to what? Is equal to 2 over 5, right? So we're
Yes.
going to make some conclusions. We're going to draw some conclusions from this. Now, the first conclusion I'm going to draw from this is this, that there's something that we can do here, right? Because B seems to be in the middle of everything, right? B seems to be in the middle of everything. So let me draw that middle of everything. So what that means is that I'm going to look for a way to express all these guys in terms of B. What that means is that for instance, A in this whole scenario is going to play out like this. A, I can do this. I can multiply both sides by B so that I'll have that A is equal to 2B over 5. Do you understand what I did back there?
Yes.
Do you understand what I did here?
Yes.
Okay, good. All right, so that means anywhere I have A, I can simply do this, right? I can put this for A. So if I go back to put this into this, what I have here, then I'm going to have that, or maybe I should also do for C. I think I should also do for C. Okay, so B over C is equal to 3 over 4. So again, the whole idea I'm trying to do here is to express everything in terms of B, because B seems to be what they have in common, and B is at the center. So I'm going to say, what will C be equal? Okay. Now, for this one, for C, it's a bit tricky. So to avoid the confusion, this is what I'm going to do. I'm going to do something called a cross multiplication. This is what it simply means. The guy under on this side is going to multiply the guy on top on the other side. And the guy under on this side is going to multiply the guy on top on the other side. What that means is that this will now become 3C equals 4B. Okay? And then remember, we want to express C in terms of B. So I now have, finally, I can divide both sides by 3 so that C will be equal to 4B over what? Over 3. So now that I have this, see what I'm going to do. I'm going to take take this and replace A wherever I have it. So it says, what's the ratio of A is to B is to C? So this is how it's going to look. A is to B is to C. It's going to look something like this. 2B over 5, right, is
Yes.
to what? Is to B. Do you understand this so far? I'm taking it one at a time. A is to B. Do you understand this so far?
Yes.
Okay, good. Now, remember, ratio is as good as what? division. So what that means is that this is equal to 2b over 5 times 1 over what? B.
Oh, okay.
Did you get that?
Yes.
So that's going to take B out of the picture, leaving me with what? 2 over 5. All right. Next. Now I've taken care of this part of the ratio. A is to B. So now I want to take care of the remaining part. All this is to C. So that's what I want to do next. So I'm going to take the answer from this one and then take it to C. Now remember that A is to B is already, okay, it's already 2 over 5. So I'm now saying is to C. Okay, and remember C is what? 4B over what? 3. So that's going to be 2 over 5. Let's take care of this first. Remember, ratio is what? Division. So that's 1 over what? C, isn't it?
Yes.
Do you agree with this so far?
Yes.
Excellent. So remember that 1 over anything means inversion of that thing, especially if that thing is a fraction. An inversion simply means whatever is the denominator becomes what? The numerator, and vice versa. So I have 2 over 5. 1 over C means 3 will go up and 4B will come down. So that's going to be times 3 over what? 4B. Okay. Can you see what I'm doing?
Yes.
All right, good. So you can now take things out. 2 can cancel itself 1 time. 2 can go into 4. How many times? 2.
5.
Then you can just attach the B there because B doesn't, play in that game. It just attaches because it's a multiplication relationship. So you're left with what? Wait a minute. Did I take something out? Okay. So you're left with what? 3 over 10B, isn't it?
Yes.
Okay.
Sorry.
All right. So where did the what?
Where did the B come from?
Do you remember when we were taking care of these guys?
Yes. Oh, okay. Sorry.
That's where it came from.
Okay.
So that's how it came about.
So you just invited it into the question.
So yes. I just applied to the question. That's it. Okay. So are you good with this?
Yes.
Okay, fine. I'm moving on now. I'll close it and then move on to the next one and say edit. Okay, so this one, which of them are we doing?
The top one.
Okay, the one that has to do with pressure, right?
Yes.
Okay, nice. Let me try green and see how it plays, if it plays nice. Okay, so it says the prism has a height of 3 meters. The volume of the prism is 18 meters cubed. The pressure on the floor due to the prism is 75 Newton per meter squared. It says work out the force exerted by the prism on the floor. So if you remember, this question looks like the one that we did yesterday. The one that had to do with the cylinder. So, but this time they're asking us for the force. I think that one too, it was the force they asked us for. But then look at it very well. They saved you some, brain racking, okay, in the terms of, oh, so what is the shape at the bottom of this prism? Okay, like in a cylinder, the shape at the bottom is a circle. In a cuboid, the shape at the bottom is usually a rectangle or a square. But in this case, this is a hexagon. You don't want to start asking yourself, what is the area of a hexagon? So they saved you all that brain racking by doing what? By giving you the height of the prism and by giving you what? The volume, okay? Remember, height and volume play nicely. How do I know? Because volume is always given by what? Area of the base times what? Times the height, isn't it? I hope you
Yes.
remember that formula. Excellent. So now that we have this settled, they told us that the volume of the prism is 18. So I'll just go and put 18 wherever I see the volume V and say equals to the area we don't know. Okay, but there's no problem. We would know it from this calculation. So we'll just put A back there, and then we'll now multiply it by the height, which we are told is what? 3 meters. And so we're looking for A. We're going to divide both sides by what?
3.
We're going to divide
3.
both sides by what?
By 3.
By 3. Thank you very much. So that's 18 divided by 3. That's 6. Yes, exactly. Yes. So we're going to have 6. So my area is 6 meters squared. Now that I know the area, just follow this formula. Okay? Follow this formula. It says that pressure is equal to what? Force per unit area. And it's the force that we're looking for. So let's put in all the things.
Seven, 3 times. Can hold. Like literally, it's 21. My bad. My brain is just freaking two, so 20. This is 225. It's an easy mistake as well. Equals 6. That's also
Hello, Noah, can you hear me?
Yes, hello.
Hello,
Yes, hello.
Noah, are you there?
Yes, I'm here. Hello.
Hello, hello, Noah, are you there?
Hello.
Okay, you can hear me. Wow, and I can't hear you. So maybe because I left the meeting. Let me try some.
Hello.
Um, okay, Noah, let's try it again. Can you hear me now?
Yes, I can hear you. Hello.
Okay. Okay, Noah, can you hear me now? You can unmute your mic. Let's see if I can hear you now.
Hello.
Are you saying something?
Hello.
Okay. Quite okay. 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 Okay, let me leave the meeting and I'll join back. Okay, so Noah, can you hear me now?
Hello. Hello.